So last class we learned about direct variation. In this class we're going to learn about inverse variation, which has some very similar qualities as direct variation does, but is pretty much the exact opposite. So some things vary inversely as opposed to directly. So this next one says the amount of time it takes to travel a given distance is inversely proportional to how fast you travel. So saying inversely proportional and directly proportional is the same as varies inversely or varies directly. Okay? For example, let's say you need to travel 60 miles. The amount of time it will take you will depend on how fast you travel. See if you can stop the video right now and fill in the table based on that, noticing that X is your rate and Y is your time, and remembering we're trying to go 60 miles. So think about what you know about distance, rate, and time to figure this out. So stop the video, fill out the table. So if you had trouble filling out the table, remember that distance, to calculate distance is equal to your rate times your time, right? So we know that we're going 60 miles, and we know that our X over here is rate. And so we already know our rate, so just for example, I could do 15 times my time, which I don't know. And so basically I'm doing 60 divided by 15 to get the time. So pretty much if you had trouble, you're just taking 60, dividing it by X every time, and you're getting the table. So notice that as the rate increases, what happens to the time? It decreases, right? So this is what happens in an inverse variation, or when two variables are inversely proportional or vary inversely. So there's more to the relationship. If you study each ordered pair, you may notice that they all have something in common. And I kind of touched on it already. Each ordered pair has 60 in common, right? So rate times time will equal the rate times the time will equal 60 every single time. In this case, it would be the X and the Y will equal 60 every single time. So if you look now, the relationship that we noticed is that if we take the X times the Y, it's going to equal 60 every single time. So that will give us these numbers, right? 15 times 4 is 60, 30 times 2 is 60, 45 times 1 1/3 is 60, 60 times 1 is 60, and so on, right? 2/3 of 90 is 60, 120 times a half is 60. So now if we look at what I have there, no matter what in this table, X times Y equals 60, if I ask you to solve that equation for Y, what are you going to get? Well, to solve that equation for Y, X times Y equals 60, well, I'm going to divide both sides by X. And then you get Y is equal to 60 over X. That 60 right there is our constant of variation in an inverse variation. So that right there is our constant. And notice, to get that constant, we had to multiply X and Y together to get it, which then means that if that's our constant, over here I'm going to write, all right, if X times Y gives me a constant, that must mean that the equation in Y equals form, you would divide both sides by X here, and the general equation would be Y equals K over X. And so that right there is going to be our form for inverse variation. Very different than Y equals Kx, which is direct variation. Inverse variation is Y equals K divided by X. So now the graph of this is probably not going to be a straight line. So let's go ahead and graph this. In order to graph it, you really need to pay attention to your X values, right? So we need to go from 15 to 120, but then on the Y-axis, we only need to go up to 4, right? So we're really going to think about what's the best way to spread this out. So let's go ahead and put our X-axis and our Y-axis here. All right, so now we need the X-axis to go from 15 to 120. So if you take a look at how many spaces we have to fill here, I would count by tens. I've tried fives, and fives doesn't seem to get up high enough. So I would go ahead and count by 10. So remember, this has to be 0. And I personally like to spread things out. So instead of this one being, I'm going to put 10 here, I'm going to go ahead and 10 and 20. I'm going to mark every other one. So I'm still counting by 10, but I'm only going to mark every other line just to spread things out. So what I'm going to do is say, all right, this one I'm going to say is 20, and then 30, 40, this one's going to be 40. You're allowed to go ahead and label every single one if you want, but I just like to save space. So 50, 60, and then 70, 80, 90, 100, right? 110, 120, right? So we only need to go up to 120, so I'm going to just stop there. So notice I'm still counting by tens, I'm just labeling every other one. And this is your x-axis, and we want to say that this is our rate. Our rate is our independent variable. The time over here. Now, notice what we have here. We only have to get up to 4, right? So if I go 1, 2, 3, 4, that's not going to take up that's very much of our graph. So let's think about it. We've got some fractions here. So let's count by a fraction. We have a half as a fraction, we've got 2/3, we've got 1 and 1/3. A half is really easy to find. 2/3 and 1/3 sometimes a little bit harder. So what my suggestion is going to be is we're going to count by thirds. So what I mean is I'm going to label every third as one whole, right? So basically, I'll show you here, this is basically a third, 2/3, and then 3/3 is 1. So I'm going to put a 1 there, right? So this one is going to be 1, and then the next one would then be 1 and 1/3, 1 and 2/3, 1 and 3/3, well that would be 2, right? So we're going to go up every 3, and it's a whole number. So here's 3, and then 1, 2, 3, and then here's 4. So if you need to stop the video, take a look at that for a second, you can. And now I'm going to encourage you to go ahead and stop the video and actually graph the ordered pairs. Just put little dots on there, don't connect it until you're done. So stop the video, graph those ordered pairs. Okay, so if you notice what I've done, 15, 4, so 15 is about halfway between 10 and 20. It is halfway between 20 and 2, so there's my 15, 4, and then 32, so you go to the right, 30 up, solid 2, 45, 1 and 1/3, so I went over between 40 and 50, right here, 1 and 1/3, so remember that's 1, 1 and 1/3. I think you guys can look at the rest and figure it out. So what I want you to look at right now is that this actually doesn't make a straight line. It actually makes a curve. And if you think about this curve, it's never going to ever hit the x-axis, and it's never going to actually hit the y-axis. Because if you think about this, we're trying to go 60 miles. So we're definitely going to be using time, and we're definitely going to have some sort of speed, right? So what happens is as time gets shorter and shorter and shorter, we're getting closer and closer and closer to the x-axis, and then as we're going this way, we're getting closer and closer and closer to the y-axis, okay? So really, the graph is this like strange little curve like this, and that's how it goes. And so it keeps going in both directions. All right, so like if we were to do this in all 4 quadrants, what it would end up looking like, and you don't need to draw this unless you have room on your paper, but what it would look like is in the first quadrant it goes like this, and then in the other quadrant, the other piece would go like this. So that's what the inverse variation would typically look like. The curves are always in opposite, not necessarily opposite quadrants, but they're always diagonally opposite from one another. So let's make some conclusions about inverse variation. The inverse variation equation always looks like this. If you think you know it, stop it and go ahead and fill it in and then come back and see if you're right. But it always looks like y equals k over x. So it's k divided by x instead of k times x. The graph of an inverse variation is not linear, which means it's not straight. If you put is not straight, that's fine, but linear is a better term. Is not linear and does not go through the origin. Or you can say 0, 0 here, so it doesn't go through the origin. Now, in an inverse variation, if you're asked to find the constant, the shortcut would be to multiply x times y. So you multiply x and y to find your constant, or you can just use the equation to find your constant. When applied to a real-world situation, an inverse variation, as one variable increases, the other variable decreases. So for example, if I bring one pie to a party, the amount each person will get is inversely proportional to the number of people at the party that want pie. So if there are fewer people, you will get a larger slice. If there are many people, your slice will be itty bitty, which you might find might happen on Pie Day when only one person remembers to bring pie. Then we have to split it 25 different ways, and so everybody has this little sliver of pie. But if lots of people bring pie on Pie Day, then you'll be able to have a bigger piece. All right, let's move on and do some examples involving inverse variation. And I do encourage you to stop the video and see if you can do 1 and 2 without my help, and then come back. So number 1, write an inverse variation with a constant of variation of -4. Well, that's easy. Remember, inverse variation is y equals the constant over x. Well, if I'm telling you the constant is -4, then it's just y equals -4 over x. Done. So now number 2, identify the constant of variation in each inverse variation. Remember, you can't identify a constant if it's not in y equals form. And the constant will always be what's above the x in an inverse variation. So you can do this one on your own. In A, k is equal to 5. B, k is equal to 1. Stop the video. Do the next 3. Welcome back. In C, this one's a little tricky. It's k is equal to -3, okay? Because remember, the negative outside there, it should pop up to the top. D, you have to get y alone to be able to really decide, so we divide both sides by x to get y alone, and you get y is equal to 2. The next one, same thing, get y alone. Divide by x, and you get, well, what you get is y equals -3 over x, and then your constant is -3. Going back to D, I said that wrong. We get y equals 2 over x, which then means our constant is 2. So number 3, the points in each table represents an inverse variation. Write the inverse variation for each. So that should say, equation. So to get the equation, remember the form of the equation is y equals your constant over x. And what we're looking for is not really the slope in this case. Another reason that we call these things k is because this is not the slope, but this is what's constant throughout the entire table, right? So if I take this table, or if I think about, if I want to find, you have to find k in order to get the equation. So think about, if I need to solve this equation for k, what I need to do is I need to multiply both sides by x, right? So then what I get, to get k, you have to do x times y. So essentially, all you have to do is take the ordered pairs in this table and multiply them together, and that will give you the constant, right? So 4 times 3, well, that's 12. -6 times -2 is 12. 1/2 times 24 is 12. 1 times 12 is 12, right? So your constant is 12. So the equation would be y equals 12 over x. And if you wanted to check to see if you were right, well, let's take an ordered pair and plug it in. So let's take 4, 3. 4 is x, y is 3. If I do 3 is equal to 12 over 4, is that a true statement? Does 3 equal 12 over 4? Yeah, 12 over 4 does equal 3. So you're good. But the equation is y equals 12 over x, right? So in inverse variation to find the constant, what you're doing to find the constant is multiplying x times y. And if you forget, if you're supposed to multiply or divide, you take the form of the equation, you solve for k, and it will tell you how to find the constant, right? So here, go ahead, stop the video, do the next one. So if you did this one correctly, you should be getting y is equal to -6 over x, right? So the form of the equation, again, y equals k over x. To find the constant, you have to multiply x and y together in all of these. 1 times -6, 1/2 times -12, -3 times 2, -1/4 times 24, gives you -6 every single time. That's why it's called a constant, because it keeps giving you the same number every time. Tables of inverse and direct variations will give you constants. tables of things that are not direct inverse variations will not give you constants. So, number 4, before you write its equation, find the constant. Write the equation. Stop the video, see if you've done it right. So you should have gotten y equals 35 over x. Okay, so another way to think about it, if you don't know what to do, if you can remember that the form of the equation is y equals kx and you need to fill in the k, take what you have. You know the point is 7, 5. So I'm going to put 7 in for x and 5 in for y. So I'm going to say 5 equals the constant over 7. Well, think about what you have to do to solve for k. To figure out k, what do? You have to multiply both sides by 7, right? And you get k is equal to 35. So that's my constant. That constant goes right there. So it's y equals 35 over x. That's your equation. So typically you're going to get problems like number 5, and question A won't be there. So it says y varies inversely as x, y equals 3 when x equals 5. The first thing that you're going to do, usually it would go straight to question B, what is x when y equals 8? The first thing you need to do in problems like this is you need to write the equation, right? So we know the equation is y equals our constant over x. So let's take what we know. We know that y is 3 when x is 5. We have to find the constant. So I'm going to put 3 where the y is. I don't know the constant yet. I put 5 where the x is. We'll solve for k. Multiply both sides by 5. And you get here, k equals 15. So now, if you don't need to do all of this work to be able to find the constant, you don't have to. Like if you look at this and know, oh, in an inverse variation to find the constant, I have to multiply x and y together, then do that, okay? So now this, though, is not our equation. Our equation is going to be y equals 15 over x. If you can get that equation by knowing you just have to multiply x and y together and write the equation, that's great. It's just that lots of people will forget what to do. And so if you can remember that the form of the equation is y equals kx and you have to find that k, fill in what you know, find k, then oftentimes it's easier. So now that's what we're going to use. We're going to use this equation down here to answer the next question. What is x when y equals 8? Well, we got to find x when y is equal to 8. So I'm going to replace in y equals 15 over x. I know that y is equal to 8. So I'm going to say 8 is equal to 15 over x. So now x is in the denominator and we have to solve for it. Remember, you can't isolate a variable that's in the denominator. So what you're going to do is you're going to multiply both sides by x. So that's what you do first. The x's on the right-hand side can cancel out because this is like x over 1, right? Over here, this becomes 8x equals 15. And so now you have to solve for x now. Get x alone, you now divide both sides by 8. Well, 15 isn't divisible by 8, but that's okay because we can write it as a fraction. So we're going to say x is equal to 15 over 8. Or go ahead and change it into a mixed number, 1 and 7/8. And that's your answer. Go ahead and try C, and then come back to see if you've done it correctly. So in this one, what is y when x is equal to 10? Well, that one's a little bit easier. We're going to say y is equal to, you're still using this same equation here, so y is equal to 15 over 10. Well, 10 doesn't go into 15 evenly, so we're just going to reduce that fraction. 15 over 10, 5 goes into 15 over 10, so we're going to say 3 over 2. Or we could say 1 and 1/2. So to be able to do a problem like this, the first thing you need to do, find that equation. All right, last question. The length L of a rectangle varies inversely with the width of the rectangle W for a rectangle of constant area A. When the length is 10, the width is 4. So there's a lot of information there, not super hard. So just like direct variation, the first thing mentioned is y. The second thing mentioned is x. So the first thing I'm going to do is I'm going to write my equation. The length varies inversely with the width. And in this case, they're calling the constant A, okay? So think about the form y equals k over x. We have all the information here, except we're going to use different letters, right? The length is mentioned first. That is y. So I'm going to say L equals, well, the constant, they said, is called a. So I'm going to put an a in the constant spot. Over x, x is width, because it says length varies inversely with width. Y, x. And then this one they said was the constant, so that's k. Okay, so I'm going to replace the x with a w. So now the first question, find the constant of variation. Well, let's use what we have. We know that the length is 10, the width is 4. So where do I put the 10? Well, I put it in for L. And I don't know the constant. And I know the width is 4. And you solve that equation. Basically, that's what you do. You take the form, you fill in the letters, you fill in what you know. Multiply both sides by 4. You get that the area, in this case, is 40. Now, think about what we're talking about. It's 40. I haven't given you a unit, but we should say 40 units squared because it's area, right? All right, so now write an equation that relates the length and the width. Now that you know the constant of variation, well, we know this right here is the equation, and we know the a is our constant, is 40. So the equation is going to be L equals 40 over W. That's the equation for this particular problem. Once you have the constant, you fill it in. The length and the width are the things that change, because there's lots of lengths and widths that you could make equal to 40, right? So then the next one is, okay, so different problem. When the width is 2, find the length. Well, we're going to take that 2, we're going to put it in there, we're going to find the length. L equals 40 over 2. Well, 40 over 2 is 20. So we're going to say the length is just 20. In this case, we're just going to say 20 units, not units squared, because it's a length. Okay? So whenever you do this, you first want to come up with your equation. Find the constant. Use that equation to answer the next bit of the question. Good luck.